Hello everyone. We are starting a free open lecture on our Discord. If you are a viewer and want to ask questions and get answers online, join our lectures. You can find the link to Discord in our Telegram channel. We are moving on to the next lecture in our basic algorithms course. And the topic number 7 is counting sort of non-negative integers. Definition. Counting sort is a sorting algorithm that counts the number of occurrences of each element in a list, and then uses this data to sort the elements. To use this algorithm, all numbers in the list must be whole, non-negative numbers. Purpose. Used in computer science programming for sorting data. And now we move on to the p-step algorithm, where we will discuss the definition and purpose in more detail. We have an array of size 10 where n equals 10, and we have our array R, 653187242, and we will create a counter array. The counter array will be created with the size of the maximum element from R plus 1, and all values in it will be set to 0. The first step says to iterate through the array R. Add 1 to the index in the counter array. The counter is an array of counts for each number. 6 adds 1 to index 6, 5 adds 1 to index 5, 3 adds 1 to index 3, 1 adds 1 to index 1, 8 adds 1 to index 8, 7 adds 1 to index 7, 1.8 adds 1 to index 8, 1.8 adds 1 to index 8, 1.8 adds 1 to index 8. 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 2. 7 increased by 1. 2 increased by 1. 1. 2 increased by 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 1. 4 will increase by 1. 3 will increase by 1, meaning there will be 2. Because there was a 3 here and a 3 here, the value here will be 2. 2 also increased by 1, resulting in 2. We move on to the next step. After this step, when we have filled the count array, I remind you that to determine the size of the count array, we need to initially find the maximum element. This would be step 0, which is not mentioned here because it is an obvious action. To find the maximum element in Python, for example, using the max function. In the context of C++ programming, you can also find it using the max element function, and accordingly we move on to step 2, which is filling by counter. We fill the array R because we do not want to allocate additional memory in this case, as we already have an array of the required size, and we will simply overwrite it and return it. We will not use any additional RAM. Accordingly, we iterate as if in the current cell at index G, there is a non-zero value, and as long as it is greater than 0. We will set the value, that is this index, as the value in the array R, and move on, or stay in place in the current scenario. So if it's greater than 0, we stay in place, subtract 1 from this count again, and sort of place this index here, and accordingly, we will iterate like this until all the counts become 0, because we will be changing them. So what do we get? Like, here is a 0, we move on. Here is a 1, we basically placed a 1. This is not actually the quantity, but essentially the index. So we placed a 1 here, decreased by 1 here, so there's 0 left here. Here it's 2, so we placed a 2 and stay in the same place. Here we placed a 2 again because there is still a value of 1 here, and we subtracted 1. Accordingly, it became 0 here. The same goes for 3s. We placed a 3, moved it, placed a 3, moved it until it became 0 here. We do the same thing here. So we move 4, place it, move 5, place it, move 6, place it, move 7, place it, move 8. Consequently, the entire array will become 0.
Want to become a great programmer? Subscribe to our Telegram channel.
That is, the entire array will also reset to 0, as it was initially when we first created it. It was all zeros. This array is temporary to determine the counts, and we can sort by these counts. Why? Can we do this? Because the indices 0, 1, 2, 3, 4, 5, 6, 7, 8 are by default in sorted order from 0 and up. That is, we don't have a situation where there's a 0 here, a 1 there, a 3 here, a 4 there, and so on. In other words, there is no chaotic order in the indices. The indices are definitely strictly sorted in ascending order. They are indeed all integers, starting from 0, so they are absolutely whole numbers. Or the set is 0, a set of non-negative numbers that are initially already sorted. And accordingly, we proceed to look at the algorithm's complexity. The algorithm's complexity is linear, that is O of n, in both the best and worst cases because we always traverse the entire array R and the entire array count or counter throughout the array of quantities and throughout the array of values. Therefore, these are two linear complexities which in this case do not depend on each other but stand parallel. That is, we will accordingly consider it through the sum of asymptotic complexity, which we discussed in our third lecture. But in reality, if we examine this point in more detail, even if we have an array, for example, of 3 elements, With a size of 3 and the maximum value there is, for instance, 9 million, it is obvious that the count array will become 9 million in size. Therefore, roughly speaking, the value O will be the maximum element of the array R. But if we delve deeper into the details, it will be the value O of the maximum value between the value n and the maximum element of the array R. Additionally, considering the intricacies, the value O will be determined by the highest value present in either n or the array R. Because if we have, for example, 9 million values, meaning the size n is 9 million and they are all ones, in the array, then our array will be created with a size of only 2, that is, with a 0 cell and a 1 cell. This refers to the counter array. It is created with a length of only 2 because we only have 2 values, 0, which will be the default, and 1 respectively, like an array consisting only of ones. However, the actual size of our array is 9 million, so the complexity, both in the best and worst cases, will be O of the maximum value, and in this case they will be the same. Therefore, we keep the complexity as OATN because the complexity is still linear. But we must not forget that even with linear complexity, it is important to consider how large it is in linear size, whether it will keep up. So, if you have an array of 9 elements, one of them is 9 million, you must consider that your algorithm will then perform 9 million operations. But if you have an array, for example, of 9 million, but all the elements are ones, it will still be 9 million because you will have to iterate through the array R, but then your count array will have only, for example, 2, 3, 4 values depending on what your maximum is. Therefore, if we delve into the details, we must not forget about this. Accordingly, the pseudocode, we have a counting sort function, and it takes n, which is the size of the array, and the array itself. Initially, we assign the maximum possible value to the 0 index of the array to have something to compare with, and then for each index I from 1 to n, if the maximum possible value is less than the current value, we assign the array to the maximum value, meaning we update it. We start from the first index because the 0 index is already saved, and there is no point in comparing the 0 index with itself. Therefore, we start from 1. For each index I from 0 to n, in the count array at the index array, we assign count array as +1. Initially there are zeros, and if such an element already exists, we need to update the value. For example, if it is 4, it should become 5, so we update it and add 1. The next step is we have I and j, which are two indices both equal to 0. While I is less than n, meaning I iterates over the array, we rewrite it in sorted order from the count array. Thus, while I is less than n, if count j is greater than 0, meaning if the count in the cell is, for example, 2, we decrease it to 1, then 0, and assign this index to array, moving one step to the right. Otherwise, we move j to the right because if the count cell at index j is 0, there is no point in staying there, and we need to move right to find the next element, where count with index j will be greater than 0 to assign anything at all, and we return the R array. Accordingly, let's look at the code in Python. It is completely analogous to the pseudocode. That is, the maximum value in the array is found in the same way. We find the maximum element in the same manner. If it's convenient for you, you can shorten this entire operation with a single command in Python, for example, simply the maximum of the array, and thus you will shorten this code. They work the same way, meaning maxArray also operates with linear complexity. Next, we iterate through the entire array and store the value accordingly in count. We add ones there since it initially contains zeros. Here, it can be added that the count array is created with zeros and multiplied by the maximum value +1. So, it is indeed created and accordingly filled. And in the same way, we go through the entire array with a while loop. But here we must not forget that we also need to decrement the count array by 1. In other words, we must not forget the decrement. The count at index j, we need to decrement by 1. The count at index j, we need to decrement by 1. Otherwise, this moment will loop because it will fill all, for example, cells where it first encountered 1 since we are not subtracting anything, and accordingly it will constantly be greater than 0. That is, if count g does not decrease, it will constantly be greater than 0. Next, we look at the code in C++, which is exactly the same analog code, where count is created in the same way with max value +1 filled with zeros. Everything is filled in the same way. We create I, j absolutely identically, iterating through I, which is less than n. Thus, it will increase each time. Decrement count at index j by 1, assign j to r and t respectively, and then return our array. Here, everything is completely analogous. All three codes are the same. With that, our lecture has come to an end. You can find more details on our website and review this lecture in a slightly different format and additional presentation. But the algorithm works the same, and you can just save all these lectures, for example, on your computer or to the hard drive, so you can repeat it all later. See you in the next lectures.
Want to become a great programmer? Subscribe to our Telegram channel.